I think it's a kind of an ugly picture. What I like to do, just to make it a little bit easier to visualize and deal with, is just kind of widen it out a little bit. And you can do this, it's fine, as long as you don't violate any of the properties that are existing in here. So I want to maintain the fact that those two things need to be parallel. And hopefully you see that this x over 2 is the same thing as that angle up there. And then this 7x is the same as that angle right there. Is that okay? So just kind of take that line there and that line there and pull them apart. It just gives a better picture, I think. And I won't give you a picture like this that's kind of that mangled and ugly. But when we do that, if we can visualize the fact that that line there and that line there are the parallel lines that we're interested in, and hopefully we realize that that is the transversal. Kind of hard to make it straight, but that transversal is the transversal that's useful, because that's the one that creates some of the angles that they provide us with, right? Hopefully you realize that even though this is a transversal down here, it's kind of pointless to have. All right, it doesn't provide us any angles that are, or it does provide us angles, but none of them are identified with algebraic expressions. So if I remove things, does that picture start to look kind of like what we've dealt with in the past? So what types of angles then would that angle there, and that angle there be in comparison to one another? They're supplementary. They're same side interior angles, right? So then the feature of them is that they're supplementary. So we're going to say x over 2 plus 7x is equal to 180. Okay? So if you're able to get that, you have done the geometry. Okay? And you can show me that you are 100% fine with the geometry. I've taught you that. You're good to go. You've learned the standard. Does that make sense? But the way they judge whether you've learned that in the course, and when they judge it on Math Excel, and they judge it at the end of the year in the end of course exam, is that they're going to not only see whether you know the geometry, but they're going to ask you, do you know the algebra that verifies that? And this is the idea, this is the thing. Like, just think about how that end of course exam is great. It's an online platform, right? So they're going to grade by trying to match up your answer to a predefined answer that they have. Well, if they're just asking you to create an equation, that's all you have to do to know whether you understand your geometry, is that, you know, one person could write x squared plus 7x equals 180. Someone else could write x squared equals 180 minus 7x. Somebody else could write, x plus 14x equals 180. Somebody else could have written 7x plus x over 2 equals 180. You see the vast amount of different equations that somebody could write that would still be true. Does that make sense? And that would be really hard for them to be able to program the test and then the way it's graded to match your answers. But what's really easy for them to do is say, okay, if they can set up that geometry, the idea is, well, they've got a year of algebra under their belt. They should be able to go and solve this and find out x to be 24. And now everybody should have gotten 24, right? And it's really easy to check everybody across the state of Ohio whether they've done it right or wrong by gauging that 24. Okay? But at the same time, not only are they challenging and trying to test you over your geometry, but trying to test your algebra. Okay? So in regards to that test, when we take it, however well you do on it, is not just a sign of whether you did good in geometry, but it's a sign of whether you did good in geometry and algebra. So if you got like a 1 or a 2 on that test, okay, hopefully at least a 2 last year in algebra, you're going to use that same material. So if you got a 2 on the algebra or a 1 on that algebra, hopefully you realize that I'm probably not going to do so hot on that geometry unless I get those things fixed between now and then. Okay? Because of how much algebra is on that test. But if you can do this, we've covered the geometry. Now we just got to go through and figure out how to solve this. Okay? We talked about yesterday, maybe the easiest thing to do when you see fractions in your word, or fractions in your equation, is try to get rid of it through multiplication, right? So we're going to multiply by the greatest, not the greatest, but the least common denominator. Okay? And now all the denominators up there are 2 and 1s, right? Put a denominator of 1 in there if we need to. So basically we're trying to say, how can I make all those, what number can I make all 3 of those denominators grow to through multiplication? And hopefully we make it a whole number, okay? So can we make them all grow to 2? Yeah, okay. Leaving the, if this one's already at 2, so it doesn't really grow, but we're going to use multiplication. And the best way to think about how you're going to multiply or what you're going to multiply by is just take your denominators. Take every one of them. Doesn't matter how many you have. Take those 3 numbers, multiply them together. And that will give you a value that you can make them all grow to. Now, it might not always be the smallest, but it doesn't really matter. Okay? That will give you a common denominator, and that's what you really need. Okay? A lot of times in practice, we try to say, let's find the least common denominator. But that's just going to make your numbers, if we find the least common denominator, it'll make my coefficient smaller, but we should still be able to do it with bigger coefficients. I'll multiply everything by 2 then. So I'm going to go through and multiply every single thing by 2. Make sure that I don't want to put parentheses around the quantities. I didn't put anything around. I should probably actually do it this way. Make sure we incorporate, I wrote it too fast, but incorporate the pluses and minuses. Does that make sense to everybody? Okay. But when I do this, okay, when I multiply that fraction by that fraction at 2x over 2, well, 2x over 2 is going to turn into what? Just x. So those cancel out. Gives me x. Okay. This is going to be 2 times 7x gives me 14x. And this is going to give me 2 times 180, which is 360. A lot of times I see people, the big mistakes I see is that we forget to multiply the 180 by 2. Okay. Or we just multiply this x over 2 by 2 and we leave the other ones as 7x and 180. You have to multiply if you're going to alter one component of the equation, you have to multiply every component of the equation. Okay? So that gives me 15x, right? So 15x is 360, divide by 15, x ends up being 24. You should be able to plug that back in, and this is every one of these problems has a built-in check to it. I plug back in that 24 over 2 is 12. 24 times 7, 7 times 4 is 28. Carry the 2, 7 times 2 is 14. Add 2, 16. So 12 and 168. What do you get when you add those 2 numbers together? 180. Okay? So the built-in check is to make sure that the number you use when you plug it back in gives you the relationship that you started with, or that you thought you should have started with. Okay? Let's say I go through this work and that was x over 2, and that was 7x. Let's say I go through all that work. Maybe I mistakenly did some algebra wrong, and I would have gotten x to be 20. We'll plug that back in. That gives me 10 there. Gives me 140 there. Do those 2 things verify the relationship that I started the problem with? No. So it tells you your algebra somewhere is wrong. Okay? And what a lot of people want to do is to say, okay, I got it wrong, I checked it, it's wrong, and then wipe everything away. Do not do that, okay? Because it's a simple mistake. Somewhere in your algebra, it's usually you added something wrong. I've been seeing a lot of people doing this on question number 9. I don't think it's a very hard question, but looking at number 9, if you're a person, don't raise your hand and tell me whether you missed it or not. But a lot of people get 77 on this, okay? And I believe the answer is really 103, and this is the reason. They say x plus x minus 26 is equal to 180. That's the geometry, 100% correct. And then they go 2x equals, we should go add 26 to both sides to get 206, right? That's where I get x to be 103. But the people that are getting 77 are doing this. They're getting 2x equals 154. Well, half of 154 is 77. What did they do? Yeah, they subtracted 26 from both sides, which is a silly mistake, right? It's not a big mistake. But we make that mistake and we just crumple our paper up or we erase everything. We can't see that mistake anymore and you come for help. If you left it, I can show you, hey, this is the only issue you made. They'll fix it real quick and you're done, right? Okay. But if you erase everything or you come back up with nothing, we have to start over from scratch, waste another 3-4 minutes to set everything up, where you really already had the bulk of all the information that you needed. So just be careful with that kind of stuff. There's other ways to do this. That's what I like about math. Okay, you might dislike it, but there's other ways of doing this. I've got x squared plus 7x equals, what do we say, 180? Okay. Can I rewrite this as, x over 2 plus 14x over 2 equals 180? Is 14 over 2 still 7? Okay. So now I've got two fractions I can add together because they have the common denominator. So I get 15x over 2 is equal to 180. Okay. Can I multiply both sides by 2 here? Which is ultimately what we did earlier in the same problem, but multiply that by 2, that by 2, that by 2, which is still multiplying both sides by 2. 15x equals 360. X is still 24. Okay. So what I want you guys to understand, what your neighbor does and how they go through the problem might be different than what makes sense to you. Is that okay? And I encourage you guys to work together, bounce ideas off of one another, that kind of stuff. But don't, just because they do it that way and you're stuck on a problem and they do it that way, doesn't mean that's the only way. Okay? Try to investigate it and learn your rules, learn your properties, your operations, so that you can do something that makes sense to you, and you can repeat that process over and over again on other problems that are similar. Okay? You're going to see more and more questions throughout the year that incorporate fractions, they incorporate radicals, they incorporate systems of equations, they incorporate factors, because those are 4 or 5 algebraic concepts that are consistent throughout the next course you take. Algebra 2, they're going to be consistent in pre-calculus, they're consistent in integrated 4, they're consistent in a stats class, consistent in calculus. So no matter what course you go into after this, if we can set the foundation of being able to add fractions, multiply fractions, divide fractions, subtract them, we can do the same thing with square roots and stuff like that. We can work with system equations. You're going to set yourself up to be very successful in those other courses, right? And right now, geometrically, we have time to do that because a lot of the stuff, I can sit here all day and say, okay, what kind of angle are those two angles, right? Or what kind of angles are those two? You already know the geometry. You've learned that pretty quickly, okay? But where we struggle is using the algebra to address that geometry. So once we learn the geometry, we're good with it, we're going to practice the algebra with it and get better at those things. Told one class this, do you guys know what area is? Kind of a stupid question, right? You know what slope is? Okay, kind of a stupid question, right? Okay. Well, you know what calculus is then. Okay, you are going to be good at calculus. You know those two things. That's all you do is talk about slope and area in calculus. Okay? Now the idea, just kind of give you a visual here, the idea of slope for lines is that they're the same all the time, right? Well, in calculus, what we do is we like to say, okay, if I got that thing right there, can you visualize that if you're standing right there, your slope isn't all that severe? But if you're standing right here, is your slope pretty steep? Okay? So in calculus, for curves, slope changes. Okay? And every single point on that curve, the slope is different. Okay? But we use y2 minus y1 over x2 minus x1 to help analyze that slope at different points. Okay? But if you understand slope, you got good foundation, a good understanding for calculus. Now, when I say area, these guys out of there, oh, guess he won't leave. But in the area aspect is, you guys know base times height and all that kind of stuff, right? 1/2 base times height for particular formula and stuff like that. What we do in calculus is we look at some curve, and now I want to know the area that's under that curve. Okay? Well, the area under that curve is going to be pretty close to the same thing as the area of that rectangle, right? So if I know the area of that rectangle, I can approximate the area of that curve. Okay? And in calculus, we go through a process that allows us to maybe refine that area a little bit better and kind of do this. Well, instead of looking at that rectangle, wouldn't I have a better approximation if I broke it up into maybe those two rectangles? Okay? Or maybe I broke it up into, maybe find the area of those 4 or 5 rectangles and then add those together. It's a better approximation for the area of that curve, right? That's all calculus is. Those two ideas, slope and that area. But inside it, in order to do that, in order to break those things up, in order to find slope of curves at different points, you have to be really, really, really good at algebra. Okay? That's why there's 3 algebra courses before you enter calculus. Okay? because to be able to do those things in area and slope, we need to make sure that we have that foundation. Same concept in this class. Some of these concepts are pretty easy, right? If I gave you just a picture and asked you to identify some angles, where they're at, relationships, that kind of stuff, you could do that, okay? Understand your theorems, your postulates, that kind of stuff. Most people can do that. But then we apply them using algebra, we struggle, okay? Because last year, maybe we didn't see the necessity that the algebra was going to provide us this year, right? You don't know what you don't know, right? You don't know what geometry now you're going to use next year. And you don't know next year what algebra 2 you're going to use the following year, right? It would be really nice if we had to kind of look in the future and say, okay, I'm going to need this stuff 2 years from now. So, and it's going to be a lot of this information I need 2 years from now. It'd be nice to have that knowledge in the back of your mind, right? Okay. That's why I try to give you that kind of insight, that foreshadowing. You're going to need this stuff. So we're going to practice system equation. We're going to practice factoring. We're going to practice working with square roots and stuff like that because of how much you use them in other courses. So that's why in that question I wanted to give you something with fractions. It's not a hard one, hopefully, because we'll eventually get some that, every single expression is a fraction and how we deal with that. Are there any others on there you guys want to talk about? I've got a couple that I know I want to talk about. 11, okay. All right, so again, what I like to do is just highlight the parallel lines, okay, and then highlight a transversal. Now, hopefully we choose the right transversal. This transversal, kind of pointless to look at because when I remove that, there's nothing there, right? There were no angles that were identified with that transversal. There are angles there. We still know what their values are, okay? And when I say values, I'm referring, I guess, to their expressions here, okay? But this one here is 3x plus 5, or plus 5 minus 5. We got 3x minus 5, and this one here is x plus 55. Now when I move that picture out, and the reason I move that picture out is kind of the practice of redrawing the image, right? I redraw it so I can get down to a picture that looks all the time something like that, whether it's rotated, flipped, whatever. But that picture looks something like this one, doesn't it? And now I can gauge and visualize what types of angles I don't know what is with this thing. It was working perfectly fine earlier today. We're going to look at that angle there and that angle there, and what types of angles are there to one of them? I'm careful. Corresponding, right? If I take this line here, let's see if I can pull that line around. Nope. If I want to take that line, I can do this with it. Okay, take that line and slide it on top of the other one. Let's take this one. Take that line and slide it on top of the other one. Do the angles of 3x minus 5 and x plus 55 kind of overlap? Okay. So they're corresponding. So if they're corresponding, what was the relationship between corresponding? They're congruent. Their measurements then are equal, right? So we get that. Subtract x from both sides. And then add 5 to both sides, so 2x equals 60. X ends up being 30. Okay? So I see a lot of people end up with x equals 25 in that case. Is that what you're saying? Okay. Small, simple mistakes, right? And it's not that you didn't know the geometry. Okay. It's just a very, very small, simple mistake of, subtracting 5 from both sides there. I see people a lot of times get like 4x equals 60. So they move this x over, but they add it to that instead of subtracting. So make sure that you know that when you're moving across an equal sign, we're using the inverse operation. Okay. To help? Any others? Before we talk about the ones I want to talk about 15 and 16 before we, at least one of those. And then that last one, 18. Some algebra there. Corey?
Number 8.
8? So there's just ask for angles 1 and 2 here. When you view these, I think that the lines up there, there's so many lines up there that get confused. They're putting S and T in there, both those transversals, and I think it gets confusing. Okay, so what I like to do is I like to just highlight that, and I highlight that transversal, just one transversal at a time, and now I'm just focusing on the purple stuff. And if I kind of do this, I know they want me to talk about angle 1, and I want to talk about angle 82. Okay, those are the things that I know right now. If I remove the picture out of there, what is the link, what is the relationship that you can see? What is the relationship that you can see between 1 and 82? Corresponding, so they should be the same, right? So measure of angle 1 is 82. Now, once I find something, I'm going to go in, I'm going to write that 82 in. See, that makes no sense. Why does it work now? That's, oh, it's frustrating. All right, so we've got 1 to be 82. So now, trying to find measure of angle 2, I'm going to look at a different transversal. I'm going to look at that transversal. Don't worry so much about that one anymore. And if this is 58, this is 2, I'm going to try to work my way through and try to find that 2. So I get this picture out of the way again. Okay, now 58 and 2 don't have a direct link to one another, right? Okay, but because one's interior and one's exterior, right? And they're on different sides of the transversal, so there's really no way that we can kind of link them. But what would this angle here be? 58. And then what is the relationship then between those two angles? Supplementary. So we said that's what? 180 minus 1, or 58, which would be what, 122? Okay. So measure of angle 2 would be 122. You could do it this way. You could say, I don't know necessarily what this angle here is, but if that's 58, don't those two have to be supplementary? So that's 122. And now what's the link between 122 and angle 2? They're equal because they're vertical. Okay, so there's several different approaches to get from one point to a new, or to the next point. So from 58 to 2, a couple different routes to go, but that is maybe a handful. Another one would be that one. That's going to be 122, right? Is that angle there and that angle there then corresponding? Okay. Any others? 12? All right, again, multiple transversals, so let's just focus on a set of parallel lines and maybe just that transversal. Okay? And I just pick a transversal. I never know which one's going to be the best one to look at first. Okay? I just pick one and see if I can learn anything about the particular problem. We know that this angle here is y minus 40, and we know that angle there is y, right? Those are the only two angles. If I look at those purple lines, those are the only two angles that are created, and I know an expression for based off those purple lines. So if I look at those, one, again, one of them is interior, one of them is exterior, okay? And they're on alternate sides, so we don't have a term for those. But we can start transferring anything we want to, okay? So would it make sense? Does it make sense that maybe I take this y minus 40 and transfer it there? Because those are alternate interior, right? And they should be congruent. Likewise, maybe we go and say, okay, I'm going to move that one there because they're vertical. And then maybe I come down and move it there because they're alternate interiors. Does that make sense? And I can play that game with a lot of different things. Maybe we move it there because they're corresponding. Okay? But hopefully the relationship that we recognize is that when I do move one of these in a logical position, maybe I move them there, what is gained from looking at those two things together? They're supplementary. They form that linear pair. So I'm going to say y plus y minus 40 is equal to 180. Okay, so it's going to be 2y is equal to Add 40 to both sides, so 220. Y then is 110. Okay, so I got Y. We now want to go back through and say, okay, we've exhausted every piece of information in regards to those parallel lines in that transversal. But we have another transversal, right? We can look at that blue transversal, okay? And we've got x plus 20 here, and we've got x plus 10, and that angle there, if I remove the picture again, maybe. Okay, so that angle there was x plus 20. That one was x plus 10. What's the relationship between those two? Yeah, there should be another linear pair. They should be supplementary. So we got x plus 20 plus x plus 10 should equal 180. We get 2x then. Move that 30 over. So it gives me 150. So x ends up having to be 75. And finding y and finding x, we're independent of one another. Maybe you're a person that solves for x first. That's fine. Okay? And then solve for y second. They don't impact one another. I want to talk real quick about one of these that's like that one. Okay, it's just 16. But 15 you do the exact same way. Okay? Because of the algebra that shows up here, I think it's important that we talk about it. If we look at those things, and hopefully you realize that there's three parallel lines there, and only two of those parallel lines are going to gain us information at a time. So if I look at, maybe it's kind of silly to do this, but make sure we understand why we want to do this. We will never pair those two up because they don't have a transversal that crosses both of them, right? We call that a common transversal. They don't have it, okay? So there's no angles that are formed by a transversal with those two parallel lines. So it makes more sense to look at those two and then cross them with that transversal, okay? And hopefully you can visualize it and tell me what is the relationship between those two angles right there that are yellow. Good, they're same side interior, so they're going to be supplementary. So we create an equation that says, 4x minus 2y plus 70 is equal to 180. Somebody in the last class said, well, I already know that one's 70. And for supplementary, doesn't this one have to be 110? So they just instantly, kind of in their head, did this. Moved that 70 over and got the relationship of 4x minus 2y equals 110. Perfectly fine. You can do it that way. All right. I go through, a lot of times I go through the kind of the long way because, I can't do, if that ends up being an expression, I can't really do that in my head, right? I have to write this down. But that's one equation. Now the problem is that we got x's and y's, right? Okay. So what we end up doing, we can't solve that. We're going to look at another set of parallel lines. This thing's frustrating. So we're at that set of parallel lines and that transversal. And again, what do you notice then about that angle there and that angle there? Same side interior again, so they're supplementary. So we should have 4x plus 2y. If that's 50, what should that one equal? 130. So I'm going to go 4x plus 2y equals 130. So there's my second equation. Okay. So we have these two equations. Okay. Now what's nice is they both have x and they both have y, right? What's even nicer, and both these questions, 15 and 16, did this, when I set them up, they're already designed so that when I add straight down, when I stack the x's on the x's and the y's on the y's, when I add straight down, what happens to your y's in this case? Cancel out. So you get 8x is equal to 240, right? Okay. So now x ends up being 30. Okay. And this is a system equation, once you solve for x one time, you go back into any equation that has x and y in it and substitute and be able to find y. So I'm going to take that 30, I'm going to plug it back in to maybe that equation there. So what's 4 times 30? be 120, right? Okay, so when I substitute, I get 120 plus 2y equals 130. 2y is going to equal 10, and then y would be 5. Okay, so x has got to be 30, and y has got to be 5 for that problem. Okay. Now, somebody in the last class said I didn't do it that way. That's fine. There's other ways. Okay, but those other ways still need us to use the geometry that equation and that equation were produced with. Okay, we still need those equations. All right, but let's do it this way. Let's say, can I take, let's just take this red equation and let's solve it for 4x. You guys agree with that? Just add 2y to both sides. Okay. Now you can solve for 4x, you can solve for 2x, you can solve for 1x, you can solve for 2y, 1y, whatever. Solve for whatever multiple of the variable you're interested in. Okay. I solve for 4x because down here in this other equation I saw a 4x. Does that make sense? So if I solve for 4x, I can do a direct substitution. Okay. Now in this equation down here, wherever I see a 4x, I'm going to put what it was equal to. So I'm going to rewrite this as 110 plus 2y plus then this 2y equals my 130. Okay? Well, did that effectively get rid of a variable? Now you've got y's, right? So how many y's you got? 4. I move that 110 to the other side, so give me 4y is equal to 20. What's y got to be? 5. Is it the same 5 we found using elimination? Yeah. And what's nice, and if I can plug that 5 back in up here, I have 4x is 110 plus y was 5, so 10. So you get 4x is equal to 120. What's x got to be? 30 again. Okay. So that substitution might work. That's fine. Somebody in the last class used, and I keep using the last class, but it was throughout the whole day. People have done this. Bring it back to where it was. Did I delete the page? If we have those two equations, can I do this? Can I solve 4x minus 2y equals 110, 4x plus 2y equals 130. Let's say that I solve this one for 2y. Okay, so doing the same process, we'll solve this one for 2y. So I get 2y is equal to 130 minus 4x. Okay? The reason maybe I would do that is because I see a 2y up here, right? So I'm going to take that 130 minus 4x and we'll plug it in for that 2y. So you get 4x minus, okay, because of that minus sign right there. But now I was minus 2y, which was one object, it was a monomial. We're going to replace it now with two objects, 130 minus 4x, right? So because they're equal, we took out a monomial and now replaced it with a binomial. So what we need to do is make sure we subtract both parts. And the way to remind ourselves to do that is we put those both parts in parentheses. Does that make sense? Okay. And then it's equal to 110. I'll show you the difference what happens if you don't do that. 4x minus 130x, because it says minus both these things. So what's minus and negative 4 turn into? Plus 4, we get 110. So now I get 8x. I don't know why I put one x with that. Add 130 to both sides. Should be 240. X still ends up being 30, right? Okay. Well, somebody in the last class did this. They said, I'm going to do this substitution, and I'm going to replace, so they're going to rewrite 4x, but they didn't put parentheses around anything. And if they don't put parentheses around anything, you don't distribute a negative, then what happens to your 4x's? They cancel out, and they were left with negative 130 is equal to 110, and they didn't know what that meant. They didn't know what to do for that. Okay? So make sure that you understand when you substitute binomials, you need to make sure that you put parentheses around them.